The Voyager program is probably the most famous program in space history. You can imagine the uproar around the world when NASA announced that it would launch 2 satellites to Jupiter and Saturn way back in 1977. So in this video, we'll be exploring the timeline of the mission, the scientific instruments in this mission, and the biggest moments in the mission. The Voyager mission was the launch of 2 twin spacecrafts, Voyager 1 and Voyager 2. Together, not physically together, they explored the outer region of the solar system and even ventured outside of our solar system later on. They gave us valuable data and made important discoveries that shaped our understanding of the solar system. At first, the Voyager missions were designed to be part of the Planetary Grand Tour, a tour involving 4 spacecrafts that would tour the solar system. However, in 1971, the tour was cancelled to fund the space shuttle instead. But in 1972, the mission was reduced to be 2 satellites and was initially designed to be part of the Mariner series, another space program that explored the inner solar system, including planets Mercury, Venus, and Mars. In March 1977, NASA decided to rename the mission as it was different from the Mariner series, and on the 20th of August 1977, at 2:29 p.m. Universal Time, Voyager 2 was launched first. Yeah, Voyager 2 was first. Its specific trajectory and alignment was only available on that date and at that time. Also, it had a longer path to take than Voyager 1. We will get onto that later. Voyager 2 followed a trajectory to visit Jupiter, Saturn, Uranus, and Neptune. A couple of weeks after Voyager 2, Voyager 1 was launched on September 5, 1977 at 12:56 p.m. Universal Time. It took a shorter and faster route to visit Saturn's moon, Titan. In the 1990s, Voyager 1 passed the space probes Pioneer 10 and 11, becoming the most distant object from the Earth. Both Voyager spacecrafts were identical, meaning they had the same 11th scientific instrument to conduct research and take readings in space. Currently, 4 of the 11 instruments are in use today. First, we will look at the essential parts that operate the spacecraft. The bus carries scientific instruments in the Voyager spacecrafts. It is like a 10-sided box with each side containing electronic instruments. The high-gain antenna sits on top of the spacecraft and points towards Earth. The antenna is used to concentrate radio waves into a narrow beam to allow signals transmitted to the Earth to be more focused and increases signal strength. It uses many design techniques to make it more efficient. The curved reflectors focus the radio waves into a beam. Yagi antennas focus the signal in a specific direction. Phased arrays steer the signals electronically without needing to move the antenna. The optical calibration target is a flat rectangle attached to the spacecraft and placed in sight of the camera. The camera uses it to adjust the brightness and color of the camera by using the vibrant color of the target, ensuring that any photos taken would be accurate. The radioisotope power system is a power system that uses heat from the decay of radioactive materials to produce electricity for the spacecraft. It is used for spacecrafts where solar power is not a possible option, as the spacecraft will go into deep space, just like the Voyager mission. The Voyager mission uses the fuel plutonium-238 as a heat source. Alpha particles are released from the plutonium and hit inner surface of the container. This releases energy and is converted into heat. Next, we will look at the currently active instruments. The CRS looks for very energetic particles in plasma, usually found in the intense radio fields around planets like Jupiter. The particles simply pass through the instrument, and the CRS will take note of its presence. This is needed to research about cosmic rays in the universe, like finding information on the energy, particles, and chemical composition of these cosmic rays. The LECP looks for energies lower and overlapping with the CRS. It has the broadest energy range of the 3 particle sensors. The LECP measures the speed of these particles by measuring the depth of the penetration. Basically, the particles hit the LECP and it looks at the depth of how far it has hit to figure out the speed of the particles. It also indicates how many particles there are around the outer planets it visits. It is needed to analyze what type of atoms the cosmic rays are made up of, track the intensity of cosmic rays, detect particles ejected from the sun during solar flares, and detect particles coming from the planets. The MAG has a variety of tasks. It measures the change in the sun's magnetic field with distance and time, determines if each outer planet has a magnetic field, and looks at the interaction of the moons and the rings of the planet with the magnetic field. This allows us to detect the planet's internal structures, enhance our knowledge of how the solar magnetic field behaves throughout the solar system, and look at the magnetic effects these interactions could create. For example, the interaction between solar flares and the magnetic field of the planet could induce current or generate auroras around the moons. Solar winds could also affect the energy transfer particle acceleration in space, which the MAG studies. The PWS and the planetary radio astronomy are attached to the spacecraft perpendicular to each other, forming a V. It is designed to detect plasma wave activity and low-frequency wave emissions in the magnetic environment of the outer planets, telling us about electron density and temperature of the space plasma. The PWS covers frequencies from 10 Hz to 56 Hz. Studying plasma allows us to see changes and identify turbulence and shock waves caused by the Sun and other planets. Before the Voyager missions, we knew little to nothing about the solar system, specifically the 4 gas giants. However, with their help, we have learned so much more about the planets, their moons, and the universe. We will now look at the Voyager's biggest scientific moments. We had not seen Jupiter, Saturn, Uranus, or Neptune up close until the Voyager missions, where they gave us these beautiful images. Before leaving the solar system, Voyager 1 took a photo of the Earth when it turned around to face the Earth for the last time. It is simply a pale blue dot and has so much meaning behind it. When the Voyagers flew by Io, one of Jupiter's many moons, it discovered volcanoes on Io's surface. This was news to everyone, as we all expected the moon to be similar to our own moon. This also proves how Jupiter has control over Jupiter's environment, such as lightning. Speaking of lightning, Voyager 1 detected lightning on Jupiter for the first time. It did this by detecting radio wave emissions caused by lightning. Then, spots of light could be seen. Although Saturn is famous for its rings discovered by Galileo centuries ago, we did not know that Jupiter, Uranus, and Neptune also had rings. That is, until Voyager 1 revealed them in 1979. We also saw the many collisions of dust particles in Saturn's rings. We found out about Jupiter's Great Red Spot back in 1666. When Voyager 1 flew by Jupiter, the storms continued to hurl. However, when Voyager 2 flew by Neptune in 1989, it discovered a giant spot with strong winds on Neptune too. This has been named the Great Dark Spot. It is believed that the winds are controlled by the heat from Neptune itself, unusual to the winds here that are controlled by the sun's heat. Found 2 moons that have water on them, Jupiter's moon Europa and Saturn's moon Enceladus. This led to other missions being launched to find out more. On the pictures of Europa the Voyagers have taken, you can see that it has a smoother surface to the other moons. You can also see dark bands spread across the surface, indicating how icy material could have flowed through those cracked jets. Geysers are jets of gas and particles erupting from the ground. Voyager 2 saw geysers on Neptune's moon Triton for the first time. These geysers could shoot gas and particles 8 kilometers high. On Earth, the geysers at Yellowstone's National Park only shoot less than 60 meters high. Voyager 1 and 2 passed Neptune in 1989 and continued to travel away from the Earth. Voyager 1 entered interstellar space, the area between stars, in 2012, while Voyager 2 entered it in 2018. It was the first time any spacecraft had ever traveled that far away from Earth. The Voyagers have been exploring a lot more than we expected. Its measurements of magnetic field strength and plasma density have spiked, suggesting that it has been exploring an unknown region. We don't really know where the Voyagers are. This one isn't really a discovery, but a fun fact. A 12-inch gold phonographic record kept in both of the Voyagers. The record acts as a time capsule, containing information about the different cultures around the world. It has 116 images of scientific information, humans, animals, plants, landscapes, and everyday Earth scenes. Like thunder, bird songs, and heartbeats, there are greetings in 55 different languages and 90-minute selections of music from around the world. Finally, it has a printed message from US President Jimmy Carter and UN Secretary General Kurt Waldheim. On the back of the record, there are instructions on how to play the record and a map of the Earth's location. If I'm going to be honest, I think the records will probably end up stranded in space before it even gets to anyone. And even if it does, it's highly unlikely that the aliens that would receive this record would even be able to operate it or understand it. The Voyager mission is truly an extraordinary mission, operating at only 32 kilobytes of memory. A simple digital watch has far more memory today. However, it has defied all odds by being able to function longer and travel further than what we had expected. The Voyagers also helped us learn so much more about the outer planets and helped us advance in our space pathway to find out more about our universe outside of our home. Thank you so much for watching this video. Please do like, subscribe, and let me know your own thoughts in the comments below. If you would like to learn about anything else to do with space. Voyager 2 followed a trajectory. 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 Voyager 2 followed a trajectory to Voyager 2 followed a trajectory to visit Jupiter, Saturn, Uranus, and Neptune.